So hello guys, and welcome to another video on exam review questions. So we are also looking at numerical integration. In the last video we looked at numerical integration by trapezoidal rule. So this video is all about Simpson's method or Simpson's rule. Okay, so this is the question. This is an exam question. They said use Simpson's rule with 7 ordinates, okay, to estimate the area of the region bounded by the curve y equal to negative x squared plus 6x plus 2. The lines x equal to 0, y equal to 0, and x equal to 6. So secondly, we have to calculate the area of the region in what above by integration, and finally we have to determine the percentage error of the estimated area to the actual area of the region. So we are going to dive into the solution of this problem. Okay, so first of all, we need to define the region in question. Okay, the region in question is bounded by the curve y equal to minus x squared plus 6x plus 2. It's also bounded by the line x equal to 0, bounded by the line x equal to 6, and bounded by the line y equal to 0. Now, permit me to do a little curve sketching. This is not necessary, but this is what I feel this particular system is going to look like. So it's going to look like something like this. So this is my y-axis, and this is my x-axis. So definitely it's gonna look like this. Okay, I know I've actually solved it before, but it's gonna look like this. Okay, the curve, we have a negative x squared, so instead of u shape we're having a dome shape because of this negative sign. So it's going to look like this. Okay, something like this. So this is the curve. So our y equal to f of x, our trigonometric our polynomial curve. So this is y-axis and this is the x-axis. Now these are the roots of this curve. So if you solve the roots of this curve, you're going to get 3 minus root 11 and 3 plus root 11. Okay, so this point is going to be 2. Is that okay? Now this horizontal this vertical line that you're seeing here, I know this line is normally called the y-axis, but sorry, I'm about to disappoint you. This line is actually called x equal to 0. So the y-axis is actually corresponding to the line x equal to 0. The y-axis is the line x equal to 0. So what about the line x equal to 6? The line x equal to 6, let's say you have it somewhere here as your 6. So this is how that line is going to look, something like this. Okay, it's a vertical line. So the line x equal to 6 is a vertical line that stretches from plus infinity to minus infinity, just like the y-axis. So the y-axis is the line x equal to 0. Okay, then the line y equal to 0 is the x-axis. So the line y equal to 0 is the x-axis. So y equal to 0 is your x-axis. Now you don't need to draw this curve in exam scenario, because definitely this is your lower limit and this is your upper limit. So what they just expect you to do in exam scenario is to evaluate the integral from the lower limit to the upper limit of your y, okay, which is minus x squared plus 6x plus 2 dx. So you use Simpson's rule to evaluate this integral, but I just wanted to draw it so that I'll give you a clearer picture of what we are dealing with here. So this is the region we are interested in. So if we take note of the line x equal to 0, the line x equal to 6, and the line y equal to 0, you'll discover that this is the region that we are actually interested in. So we want to find the area enclosed by this particular region. So the area enclosed by this region is going to be the integral, okay, from x equal to 0 to x equal to 6. Then we are going to consider this particular curved equation which is bounded by x squared plus 6x plus 2. So we are going to evaluate this particular integral over here to actually figure out the value of the shaded portion. I hope you understand this. So now let's dive into Simpson's rule proper. Now that you've understood what we want to do, so we are going to say let I be, just like I stated above, you have 0, 6, then you now have minus x squared plus 6x plus 2, then the x. So what you now want to do in this particular scenario is to use Simpson's rule to evaluate this particular integral. They said in the question that we should work with 7 ordinates. So 7 ordinates means y0, y1, y2, y3, y4, y5, y6. Is that okay? So 1, 2, 3, 4, 5, 6, 7. So the last value here will tell you the value of n that you're interested in, which is what? 6. So in this case, we can get our h, or we can get our delta x by actually taking the upper limit and subtracting the lower limit of the integral. 6 minus 0, and we'll now divide by 6. Take note, when you're working with Simpson's rule, you should make sure that n is always even. So n should be even. That is why instead of us to use 7 to divide our interval, we are going to use 6. Is that okay? So 7 ordinates or 7 points actually runs from 0 to 6. In the case of Simpson's rule. So you now have 6 over 6, which is equal to 1. So our step or our h is what? 1. So we are moving in steps of 1. Is that okay? So now that we've established this, so we now have to find our I as delta x over 3. That's the formula. And into the first value is y0 plus the last value is y6. Then we're going to multiply 4 by all the odd values, which is y1 plus y3 plus y5. Then we are going to multiply 2 and by the sum of all even values, which is y2 plus y4, all even values in between. So this is Simpson's formula. First value plus last value plus 4 times all the odd ordinates, 4 times the sum of all the odd ordinates, then plus 2 times the sum of all the even ordinates in between the first and the last value. Okay, so we now have to obtain these ordinates. And how do we obtain these ordinates? Very good, we need to create our table. Okay, so let's create our table. So this is how our table is going to be. So we'll create the table as usual. I'm going to start with my index. My index is labeled from 0 to n. So you have 0, 1, 2, 3, 4, 5, 6. So I've gotten my index 0 to 6. Then the next is my x sub n. Okay, x sub n. So x sub n will also go from 0 to 6. And this 0 that we're talking about is actually the lower limit of the integral, and this 6 is the upper limit of the integral. Is that okay? So how did we get the upper limit of the integral? Remember, they said calculate the area bounded by. Okay, so because of this bound, this line has now made us to take this as the upper limit of the integral, and this line x equal to 0 has made us to take this as the lower limit of the integral. Is that okay? So I hope we are clear on that. So I'm going to run from 0 to 6. So I'm going to go in steps of delta x or in steps of h. So if I'm going from 0 to 6 in steps of 1, which is my delta h, delta x, I'm going to have 0, then you have 1, then you have 2, then you have 3, you have 4, you have 5, and you have 6. Is that okay? So we'll calculate our yn. Our yn is actually going to be the equation that we are given, minus xn squared and plus 6xn, then you now have plus 2. Is that okay? So you're going to arrange this particular expression in your scientific calculator, and you now plug in these values subsequently. So this is what I mean. In my scientific calculator, I'm going to say minus x squared, okay, minus something squared plus 6 times something, then plus 2. Okay, that's minus x squared plus 6x plus 2. So let's start with when that something is 0. So when that something is 0, we'll have 2. Is that okay? So when x is 0, our ordinate is 2. So when x is 1, our ordinate is 9. When x is 2, our ordinate is 18. I hope this is working very well. Let me be sure. Minus 1 times. Okay, so when x is 1, let me calculate for 1. Oh, it's a 7. So sometimes this, my calculator, I have to be very strict with the way I press values, but in your own scientific calculator, you could actually be very flexible. You don't need to put all these times, all you just need to work with is bracket. So when x is 2, we have 10. When x is 3, we have what? 11. When x is 4, what do we have? 10. When x is 5, what do we have? 7. And when x is 6, definitely, what are we gonna have? We can guess. Oh, 2. So we have 2. So these are our ordinates for the corresponding x values. So the next thing that you're going to do is to just use these values in Simpson's formula. So our I, which is the integral from 0 to 6 of minus x squared plus 6x plus 2 dx, is going to be delta x over 3 brackets your y naught plus your yl, which is the last value is y6, then plus 4 times y1 plus y3 plus y5. That's all the odd values, and plus 2 times all the in-between even values, which is y2 and y4. Is that okay? So we're going to get that from the table. Delta x is already 1. That's upper limit of integral minus lower limit of integral divided by number of points divided by n, number of intervals, n, giving me 6 over 6, which is 1. Okay, so that is how we actually got delta x. Okay, so delta x is equal to 6 minus 0 over 6. So our I is going to be 1 over 3 brackets. What is our y naught? Our y naught is the first value, which is 2, and the last value, which is 6, is y6. It's okay, 2 and 2, they are both the same. So you have 2 plus 2, then plus 4 brackets y1 plus y3 plus y5. So we have y1, this is y1, y3, y5, 7, 11, 7. Okay, you have 7 plus 11 plus 7, and you now have plus 2 brackets y2 plus y4, 2 brackets y2 plus y4. So y2 is 10 and y4 is 10. So 2 brackets 10 plus 10, like this. So we're going to evaluate this on our calculator, or 1 over 3, and you now have 2 plus 2 is 4 plus 7 plus 7, 14 plus 11, 25, 4 into what? 25 plus 2 into 20. So we are going to evaluate this and see what we get. Okay, so we have 1 over 3 times 4 plus 4 times 25 is 100 plus 40. Okay, so this gives me a 48. So it's equal to 48. So I is equal to 48 square units. Okay, for area under the curve. So this was with Simpson's rule. So they want us in II to evaluate it analytically by integration, as you can see from the question. Calculate the area of the region by integration. So we are going to use integration to evaluate it. Remember, I is equal to integral from 0 to 6, which is the bounds. Then you now have negative x squared plus 6x plus 2 dx. So evaluating it by your rule of integration, this will become minus x3 over 3. And plus, if you evaluate this, you have 6x squared all over 2. And if you evaluate this, you get 2x. There's no need for constant of integration because you're dealing with a definite integral. So if you solve further, you're going to have minus x cubed over 3 and plus 3x squared and plus 2x from 0 to 6. So I is going to be, we're going to solve this when x is 6, minus 6 cubed over 3 plus 3 into what? 6 square plus 2 into 6. Then we're going to subtract from when x is 0. So you have 0 plus 0 plus 0. Is that okay? Because when you input 0 into this, it will all result in 0. So let's solve and see what I will be. So we have minus 1 times, open, you have 6 raised to the power of 3 over 3. If you have a scientific calculator, you could just evaluate that quickly. Then plus 3 times 6 squared, then plus 2 times 6. Oh, I didn't put the times. Oh, it's also 48. Amazing. So we have 48.00 SQ units. So the analytical value gave me 48. So the last value wants me to calculate the percentage error of the estimated area to the actual area of the region. And they want me to correct to 2 decimal places. Well, they're already the same, but just to fulfill our righteousness, percentage error is equal to actual value minus approximated all over what? Actual. Okay, actual value minus the approximated value all over actual value times 100. Okay, everything will be in percent like this. So just in case you're dealing with another question that they ask you to find the percentage error. So percentage error is actual minus approximate all over what? Actual value times 100 over 1. So this is absolute value. Okay, absolute value. So the actual value is 48.00 minus the approximate value was also 48.00 all over the actual value was 48.00 times 100 over 1. So we have 0.00 times 100%, which is going to be 0.00, okay, percent. So using Simpson's rule, we got our percentage error to be 0.00% to 2 decimal places, which is like accuracy at its peak. So this is the peak of accuracy. Simpson's rule helps us to evaluate integral, and we have seen that it can get almost exactly as accurate as the analytical methods used to evaluate those integrals. So I hope you understand the procedure to solving this particular question, and I hope you understood how to solve this problem. And if there is any question, you can feel free to leave it on the comment section, and don't forget to like and subscribe to my channel, hit the notification bell to stay updated. And we are going to review some more numerical methods in upcoming videos, numerical differentiation, Lagrange interpolations, and Newton divided interpolatory methods, and all those numerical methods even hopefully including the Runge-Kutta fourth order method of solving second order differential equations. So thank you for watching, and stay tuned, stay safe.